Hey guys, welcome back to Intro to Calculus. This is Derivatives Part 6, and today we'll be discussing local extrema, which is essentially local maxes and mins. Now, if you can remember from like algebra or pre-calc, the local maxes and mins are kind of interesting because they operate a little differently. They are points where the immediate point before and after are either greater or less than. So for a max, that is the highest point in its neighboring vicinity. Anything after will be less. Anything before will also be less. And same with, or it's the opposite with mins, where everything after will be greater and everything before will be less in its immediate vicinity. It's all relative. And you can't have local maxes and at endpoints because you can't determine the behavior of the graph after, if that makes sense. So you wouldn't be able to know if the graph continues to increase or decrease. So that is an important distinction to make. Now, how does this apply to derivatives? Well, let's take a function, sine of x, right? And let's think of the graph. We all know the graph for sine of x, right? Something like that, right? Over 0 to 2 pi. Now, could you tell me the local maxes and mins? Probably, right? You have one at 1, and you have one at -1, right? Now, how can I use derivatives to tell me mathematically? Well, if we take the derivative of sine, it's equal to cosine, right? And let's graph cosine real quick. It looks something like this over a period of 0 to 2 pi, right? And what you can do mathematically is set the derivative, so in this case cosine equal to 0, and solve for x. So in this case, what makes cosine 0 is pi over 2 and 3 pi over 2 in this interval, right? And these are known as critical points. Critical points are where local extrema occur on the original function. And how can you tell? Well, first you can either plug it into the original function sine of x to find if it's a local max or min, or we can look at the graph of the derivative, right? So obviously we know that if the derivative is positive, that means the function is increasing. If the derivative is negative, it's decreasing. So, and it lines up with sine of x, right? Because it's increasing all the way to where the first time it's 0, which is pi over 2, and then it starts decreasing. Logically, that is a local max because it gets to a point and then it starts decreasing. That is the highest. And then same with the other 3 pi over 2. When we get to 3 pi over 2, it's been decreasing for a while and then it starts increasing right after 3 pi over 2. Therefore, it's the lowest. So those are the points at which you have the critical points, which makes sense with sine pi or sine of x, because if you plug in pi over 2 and 3 pi over 2, you will find your local maxes and mins. So that is basically how you can use derivatives to find local maxes and mins of functions.